So you want to learn how to climb, clamber, mount, or whatever the new term for it is in Godot? Well, not so fast. Let's learn some theory first. This is the player and he gets a raycast. As the player moves through the world, we want to check if the raycast is colliding with something when the player jumps, and if it is, call the climbing function. However, if we just check for that ray colliding, he could just vault through a wall like it's nothing. So how do we combat this? Well, we'll give the raycast a friend named headRay, and call the original raycast chestRay. When we jump, we can call a function that checks if the chest ray is colliding, and if it returns true, we see if head ray is colliding. In the case that head ray is not colliding, we call a function to climb the ledge, otherwise we return false and the player just jumps. So, with that idea in mind, let's see how it works out in practice. Okay, so first off, in order to do anything, we're gonna have to figure out some sort of way to find out if the player is able to climb over an obstacle such as this block, which you can see here. So the easiest way to do this is to create a set of raycasts that will check that will check what we like if there's a wall there or not. So we can say this is chest ray because it's up against the chest, and this is, we can really put that around there because we want to give a lot of liberty to what can be climbed over, and we need an array of rays, so we can say these are head rays, and then we can just take that, put that in there, head, I'll just name it like center, so that way we know this is the, so if we're gonna have an array of these, we're gonna need two more. We can just put one like that, and put one like that. And we can rename these. This one is center, this one is right, this one is left. It's technically not super necessary that you name these because we're just going to iterate over them with a for statement, but it is nice for organizational purposes. And here we're going to need to create a new set of these, and these will double check how, like if there's something that's above the player that the player is gonna end up colliding into. So we can just set these really, really high out, and this is center up, right up, and then left up. And none of these rays up here, if any of these rays are colliding, we make it so the player can't clamber over the wall. So now that we have this, let's hop into the code. So as you can see, this is using the boilerplate code that Godot has when you create a new script for Character Body 3D. It just has some minor modifications like this camera stuff. Assuming you probably already have a character controller similar enough, so we'll probably be fine. And next we need to set some restraints to make sure that the player isn't doing stuff when we don't want it to. So we can have these conditional variables. We're gonna have a can jump variable which will set to false when we're in the clambering state. so it can't jump and like mess it all up and get like really glitchy and stuff. We're gonna need a var camera can move. We're gonna set that to true, and then we'll also disable that. And then if you're gonna end up having a different crouching and uncrouch, which I'm not, you can also say make a variable for is crouching and set that to false by default. And so whenever in your code you're crouching, you can just set that to true, and then you can set up a different animation for clambering with just crouching. So now that we have these variables, we can make the functions for movement. And first one is we can climb, which should return a boolean if not $head slash chest array dot is colliding, return false. So if the chest array is not colliding, you can't climb. It's going to return false. And in order to see if these ones here, the ones that can't collide, we're going to have to set up some sort of system to iterate over we have to iterate over the different raycasts. So we can say for ray, which will be the raycast, in $head slash headrays dot get children. So this will get the children of each ray in the children. So this is just kind of like a stored value. It's technically being read as like a number. It's basically a variable with a number assigned to it, and that number assigned to it is whatever count of children there are here. So we'll say if that array is colliding, we can also return false. And otherwise we can return true if all of these checks end up getting passed. We're gonna have to implement that into our code. So if under our jump here, we're gonna set that to, we're gonna add the can jump. So this is just saying and can jump. This is basically and can jump equals true, but it's just a lot shorter and more readable. And this is obviously if can jump is equal to false, we jump. If all of this is met, we can jump. And else if input dot is, actually just press jump, and can climb, we can call a function climb. This function isn't created yet, so we can move it up here, function climb. We can just simply pass for now. And if you want to make sure that they have to be on the ground when they climb, you can just add this and is on floor. But in my case, I don't really need that, so I'm just going to leave it as this. So in this climb code, we're going to have to set up some, we're going to use those conditional variables from before and set up some movement restrictions. So first of all, we're going to have to set the player's velocity to vector 3.0. which will kill off all velocity there is, so when they leave the animation, you don't go flying everywhere. Can jump is equal to false. We're going to say camera can move equals false, because we're going to set up animations for the camera as well. If you don't really care about that, you can leave that as well. It doesn't really matter. Now we're going to set up some variables for how long we want it to take in order for the animation to finish. So we're going to say var vertical move time is equal to 0.4 seconds, and the horizontal move time is equal to 0.2 seconds. So if we are not crouching, we can set up our vertical transforms. I'm going to say vertical movement is equal to global transform dot origin plus vector 3 0, however tall your player collider is, and then 0, because this is the x, y, and z value. Move. Okay, fix that. So this vector 3 is basically stored as a position, and it will move our character up by whatever this y number is. If you want to move it forward or backwards, this is your z, and this is your x for left and right. But we aren't going to do anything with the z because we need to make a separate animation after that, after we climb up this high. So we can say the vertical movement tween is equal to get tree dot create tween, and we can set the transition to tween dot trans cubic, and set the easing to tween dot ease in. So this will make our animations a little bit smoother, and obviously if you want to change them up, you can change that as well. Those are just the ones I want to do. So we can also set up a camera tween, and that equals get tree dot create tween, not timer, and we can set the transition to trans cubic, and set the ease to ease tween dot ease in. So those are our tweens that we can use for our vertical movement. Okay, so our vertical is going to, we're going to set the tween property of it, which will be what our movement is. So vm tween dot tween property self, so we're going to move our self or character body, and we're going to say global transform, and instead of a dot we'll use a colon for origin, and then we can say vertical movement and vertical move time. And if you wanted to, you can just put a global transform.origin plus vector 3 into here instead. It's just, in my opinion, easier to have a few variables that you can easily tweak instead of digging around to find where they're referenced. So now that we have our vertical movement, we can set up a camera tween dot tween property, and in our code we should have a variable that says camera, and that references the camera. So we can say, instead of self, we can say once we're going to move the camera, and instead of a global transform, because we only want to rotate it, we can say rotation degrees. And instead of .x, it's a colon x. And we're going to say clamp camera dot rotation degrees dot x minus 20.0 minus 85 and 90. Or in your camera code, whatever these two are, you can just put there. And now we have a rotation. We can just pass in the vertical move time for ease of access. Now, in order to rotate it on the Z, or have it like a, I guess would be like a facing forward rotation instead of like a leaning forward, we can say camera tween property camera rotation degrees Z is a, put it parentheses, we can say -5 times sine of a random float range of -10,000 to 10,000, and we can set vertical move time. Now we want to wait for these to finish. Between dot finished. So our finishing, so horizontal movement is going to have to wait until this movement has finished, so we can actually move forward and like over a wall instead of just into a wall. We're going to set up our horizontal transforms. You can say forward movement is equal to global transform dot origin plus head dot basis dot z, but because forwards in Godot is -z, we can put a negative before the whole thing, and we can just multiply that by 1.2. So forward movement tween is equal to get tree dot create tween dot set transition to tween dot translinear, and we're gonna have to reset the camera, so we're gonna say var camera reset equals get tree dot create tween dot set tween dot trans cubic, and easing to tween dot ease in. So we can now basically copy what we had up here, except make that forward movement and make that forward movement and horizontal move time. Our camera reset is just gonna take these originals and set this stuff to just 0.0 and 0.0, and the horizontal move time. Okay, so now our camera goes back to its position, the player has moved forward, and this all comes after our vertical movement is finished. So now I think we get to test this. Hold on, I guess the jumping is broken. Oh yeah, I forgot. We need to reset the can jump and can move. So we go here, grab these, we're gonna say reset restrictions, can jump equals false, true, and true. So that way, we can jump, and we can climb. And if you want to edit the values on these, it's quite easy, because you can just say, oh, rotate on the X, it's just going to be like, let's say minus 100, and see how that goes like way farther, but it's clamped off, so it's still fine. You can just set that to 10. It's kind of a smallish movement, and that way we can have all of that. Now, back to what I said about, because we remember we have this if crouching, we can say else, and this is where you can pass in any other transforms you want. I'll just simply quickly put this together to not take up a bunch of time, but basically this is if we are crouching, it's going to do this. If we're just standing, it's going to do this, and this is obviously assuming you have crouching in your current character controller. But if you want to learn how to make procedural edgeware with Blender's geometry nodes, you're going to want to watch this video here.